This is the Z transform and related ROC. C part of the question, somewhat more change in the question. Question is mentioned to us and we write expression of Z directly. Xz is minus half minus Z upon Z minus 3. Before subtracting, we check for ROC. Again draw unit radius circle and mark. This term have ROC is greater than half. This term ROC is less than 1 by 3. Now I draw a circle having radius half. This is one radius circle. This is half radius circle. Exterior of this circle. Now I am drawing second Z ROC with circle radius of the circle is 1 by 3. With 1 by 3 radius, I draw this in this way. Interior of the circle. Exterior of the circle, interior. By viewing this diagram, there is no common ROC. No common ROC means no Z transform. Z transform is not exist because no common ROC. As in Laplace, same in Z. If no common ROC, no Z transform. Z transform does not exist. For this expression, we took one more example, modern. In this example, lot of conditions. An, if A is greater than 1, A is less than 1. I took first case, A is oscillate between 0 to 1. A may be negative, but we are not considering here right now. From 0 to 1, if A is 0 to 1, the expression is an un plus a minus n u of minus n minus 1. Complete expression for us is, and I am drawing this expression, a is in between. I took a value, so drawing is very easy. I took half. With the half, I put here half in between any value, half 1 by 3, 1 by 4, 2 power n u of minus n minus 1. N equals to 0, it is 1. N equals to 1, it is half, 1 by 4, 1 by 8, and so on. Draw of a mod n where a is in between. If negative, I put again minus 1, 1 by 2, 1 by 4, and so on. This is the actual draw of this signal when a in the range of this. I directly write expression for this z upon z minus half with ROC attached half. Second time I rewrite expression for this, sorry, it is generalized a z is greater than a. In this case also I write expression minus z upon z minus 2 where ROC is less than 2. In case we took half, the ROC in the range of 2, half to 2. In not generalized case, it is a variable, then z upon z minus 1 upon a with negative sign. ROC is less than 1 upon a. We add these two terms and I write down the final expression, these two terms. If generalized expression come from directly taking z transform of this term, correct one, this one, correct one, with ROC attached, we can write final expression xz equals to, by subtracting these two terms and rearranging some terms, z upon z minus a, z minus 1 upon a, where ROC is defined in this way: overlapped ROC, overlapped ROC, common ROC for these two terms, and final answer for us is, if a is greater than 1, then I draw again complete expression is a n un plus a minus n u of minus n minus 1. For a is greater than 1, I took a equals to 2 and write expression again for this, and now I draw it. With the draw, lot of clarity to us. It provides lot of clarity to us, pictorial view, conceptual clarity to us. If n equals to 0 is 1, if n equals to 1 it is 2. It is, this diagram is not scaled. It is 4, 8, 16 and so on. 1, 2, 3, 4, 5. As in negative also, minus 1, I put minus 1, it is 2, 4, 8, 16 and so on. Complete diagram. By taking z transform, z upon z minus a, ROC is greater than a, z upon z minus 1 upon a, 1 upon a, ROC is less than 1 upon a with negative sign. By subtraction of these two, we get the result where a is greater than 1. Greater than 1 means, by drawing ROC we can understand. I draw a unit circle here, 1 radius circle. A is greater than 1, first case, when I write an expression z upon z minus a, minus z upon 1 minus 1 upon a less than a. In first case, a is greater than 1. Greater than 1, I draw this first case. Greater than 1 case, it may be 2, 3, 3 by 2, any value. Exterior of the circle. Exterior of the circle. In the second case, a is also greater than 1. In ROC is 1 upon a. In the second case, it is also greater than 1, means ROC is, in first case I took 2 as an example, greater than 2. In same case, it is less than half. It is less than half, means in second case it is interior of the circle. No common overlap area, means no Z transform in second case. Question: we want to calculate Z transform of this pattern, this sequence. For calculation of Z transform, use Euler formula. I expand this term with Euler formula 1 upon 2j 1 by 3 e power j pi by 4 n power n un. Same I write second term also. Directly we write down Z transform over it. 4 n z inverse 1 by 2j 1 minus pi by 4 z inverse. These two term completely specified Z transform, but ROC is remaining term. For ROC, this term is responsible. Z power minus 1. Mod of this should be less than 1. This is the angle portion of the expression. Angle portion does not play any role in the ROC. Means Z should be greater than 1 by 3. ROC of this expression is this. Z does not play any role in ROC. Angle of Z does not play any role in ROC. Move to next level of question. Xn is A del n impulse. Xz is, by putting into the formula, we can directly write the Z transform of this is putting zero value in it, and we get a result for all Z, entire Z. Xn is un. Z transform we can directly write, otherwise through formula. If I directly write Z is greater than 1, for this u of minus n minus 1, now I can't directly write because it is not standard. So I have to put into the formula xn minus sign, limit is squeezed from minus infinite to 0, z minus n is replaced with minus n, zn. By adjusting the limit minus zn. Limit adjustment in this case, discrete case, no sign change. Sign is continue. In integration, we are changing lower limit into upper limit and upper limit into lower limit. There is also sign change also, but in this case no sign change. There is gp, infinite gp. First term of gp is 1 plus z square and so on. First term 1 upon z plus 1 minus with minus sign. Last answer of this term is minus z. Last answer of this term is 1 upon z minus 1. ROC is z less than 1. Our answer. If we modify question by some amount, xn is minus u minus n minus 1 Then what is the z transform of this is minus n minus 1 z of minus n. This term is responsible for limit on only. Our limit is from minus 1 to minus infinite, 1 minus ahead, z minus 1. N is replaced with minus n. Complete expression is zn. Now it is a gb minus z, z square, z cube and so on. First term in this case is z upon 1 minus z minus. Rearranging this term, it is same as un, means un and minus u minus n minus 1 both have same z transform, z upon z minus 1, but difference is ROC. Difference of ROC is, in un case ROC is greater than 1. In this case ROC is, what is ROC? Z is less than 1. In both case only ROC differ, remaining terms are same. Now we will discuss some finite discrete sequence Z transform. First example, xn equals to 1 2 3 4. We want to calculate Z transform of this xz by putting into the formula minus infinite to infinite xn. We can calculate Z transform of this. In this formula, xn z minus n. In this sequence, no arrow mark means first term is 0, location term. By putting all the values, 0 means 1, 2 means 2z inverse, 3 means 3z square, 4z cube. Comment on ROC. ROC is entire z plane, but some exception is there. Exception come from this term. It is finite term. If z, by putting z equals to 0, xz is infinite. No region of convergence means accepted except z equals to 0. Infinite is included in it.